Students, this is your reference booklet, Unit 1, Geometry, Grammar, Logic. So we're going to talk about basic definitions. A conditional is something that is an if-then statement. So think if, then, better known as cause and effect. And the symbols we use for that is if P, then Q. If P, then Q. Inverse, you switch that order. So that's going to be if Q, then P. That's converse, you switch. If Q, then P. Inverse, you keep the order, but you flip it or negate, so it's if opposite of P, then opposite of Q. And the longest one, contrapositive, you switch and negate. It's the longest word, you do the most with it. So it's opposite Q, then opposite P. The next section is called inductive and deductive reasoning. Now this, you honestly understand this quite instinctively. Let me give you a couple examples. Inductive and deductive reasoning. In inductive reasoning, okay, circle the word in, you take in multiple observations of something and you discover a truth. You discover truth. You take in multiple observations and you discover a truth. Deductive reasoning is you start with a generalized truth and then you apply it to a specific situation. Let me give you a math example. Long time ago, the Greek mathematician Euclid measured the angles in a triangle. Thousands and thousands of them, different kinds of triangles, all different kinds of triangles, measured their angles. Took the time to measure all those angles. And after literally hundreds and hundreds of measurements of flat triangles on a piece of paper, on a flat surface, he came to the truth that if you have a triangle, then the three angles sum 180 degrees. So he discovered that triangles add up to, on a flat surface, 180 degrees. That was done almost 3,000 years ago. But it took the experimentation. So that's called discovering truth. That's inductive reasoning. Deductive is like this. You take the truth, triangles add up to 180, and you apply it to a certain situation. So for example, let's say I have a problem here where up here this is 60 degrees, down here it's 70 degrees, and I want to find this angle right here, we'll call it x degrees. You take the general truth, all triangles add up to 180, and you apply it to this situation. So you would solve it. That's called deductive reasoning. So 60 plus 70 plus x equals 180, and then you would solve. Again, discover truth, inductive reasoning. apply truth, deductive reasoning. Couple logic laws. One simple law is called the law of contrapositive, and that is if you have a conditional if P then Q, if P then Q is true, then only the contrapositive is forced to be true. So that's opposite Q, then opposite P. Law of syllogism says this, is if you have a logic concept of if P then Q, and if Q then R, you add a third statement, then you can, and both of these are true, you can connect this P to R. Then what must be true would be if P, then R. Now this sounds complicated, but you, honestly, you're an expert of this. Let me give you a familiar example that parents and teachers that we're pretty much infamous for. Ready? So right here, it would read like this. If you get good grades, then you get into a good college. If you get into a good college, then you can get a good job. Therefore, we make the connection. If you get good grades, therefore you get a good job. That would be a syllogism. Okay, two more rules here. A conjunction is true. Conjunction is an and statement. And we use this symbol, a little caret. A conjunction is true only when both statements are true. So if I write something like this, Sally is in geometry and biology. This and statement is only going to be true if Sally is actually in both geometry and biology. That's for a conjunction or an and statement. A disjunction is true, or an or statement, only if both statements are false. Let me give you an example. If I have the statement that Sally is in geometry or algebra 2, this is true, this is false. If that were true and that were false, it still could be considered true because she only has to be in one, because it's one or the other. The only way it would be false is if both statements were false, and let's say she was in calculus or something, okay? Okay, those are your basic logic laws. The ones that we didn't cover in class, just be familiar with them. We're honestly going to use them later on in the semester. A couple other logic laws you need to be familiar with is algebraic properties. These you already know, you just need them for reference. The distributive property says this: if you have something on the outside of the parentheses, you can do this. That's called distributive property. The addition and subtraction of real numbers. We use this when we simply add or subtract on one side of the equal sign. So the next step here would be 5x minus 2x. We would write 3x equals 12. That's called addition and subtraction of real numbers. Versus the addition and subtraction property. Whenever you see property, you're working on two sides of the equal sign. So for example, if I'm solving here and I go like this, plus 2 on one side, I cross the equal sign and I write plus 2, that would be considered the addition property. Property happens on both sides of the equal sign. Multiplication and division property, same concept. It's where you are using multiplication or division on both sides of the equal sign. So for example, if I want to get x by itself, I'm going to times, and I have 1/4 x, I'm going to times by the reciprocal. That would be considered the multiplication property. If you have a proportion, you can cross multiply. So that's considered the cross multiplication property. When you have a proportion, you can cross multiply. When you do cross multiply, please don't distribute in your head. Write it out. Last one, or second to last one, is this. The square root or square property. To undo a square root, or to undo an exponent, x squared, you square root both sides. So this would end up being x equals 8. Be very, very careful. When you see that 2 in the exponent, you do not divide by 2 and end up with x32. You don't undo a square by dividing by 2. You square root. Last one's really simple to understand. If I have substitution, I have 3x equals something and x equals 8. I circle 8. I substitute it. I can put an 8 there. And therefore, I substitute it in, and that would be 24.